In this video, I'm going to describe and prove some properties of the circumcenter of a triangle. Consider triangle ABC on the left, which is acute, and on the right, an obtuse triangle. The first property that we're going to prove is that the three perpendicular bisectors of a triangle intersect at a single point, and this point is called the circumcenter. In this example, the point O highlighted here is the circumcenter. The second property that we're going to prove is that the circumcenter is equidistant from the three vertices of the triangle. In this example, the three purple lines are all the same length. Since the distance from O to all three vertices is the same, it means that a circle can be drawn with O as center and this length as the radius. This circle is called the circumcircle, and it will completely enclose the triangle. The third property that we are going to prove relates to the measure of the circumcenter to vertex angle. These angles are called central angles. So for an acute triangle, the measure of a central angle is twice the measure of the angle at the opposing vertex. For example, for the acute triangle on the left, the angle AOC, marked in green, will be twice the measure of angle B, the opposite vertex angle. Here it's marked in yellow. The same thing will apply to the other central angles as well. Now for the obtuse triangle, the formula is different for the obtuse angle. The central angle AOC opposite the obtuse angle B will measure twice 180 minus angle B. The final property relates to the location of the circumcenter. For an acute triangle, it will lie inside the triangle. For an obtuse triangle, it will lie outside the triangle. And for a right angle triangle, the circumcenter coincides with the midpoint of the hypotenuse. Now let's look at how we can prove some of these properties. The first proof is to show that all three perpendicular bisectors will intersect at a single point. First, I'm going to draw two perpendicular bisectors of the triangle, and these two intersect at point O. Next, I'm going to connect point O to the midpoint of side AB, which is F, with a dotted line. I'm going to prove that OF is a perpendicular bisector of AB. In other words, the angle OFA, shown here, is 90 degrees. The first step is to connect O to all the vertices of the triangle. First, let's consider these two triangles highlighted here. These two triangles are congruent because these sides are equal, the angles are equal, and there's a shared side. So by the SAS rule, these two triangles are congruent. Since the triangles are congruent, it means the length OB is the same as length OC. Now if you look at the next two triangles highlighted here, the same reasoning applies. The two triangles are congruent, so the length of OC will be the same as the length of OA. So that means that the length OB, OC and OA are all the same, highlighted here in purple. Now let's look at these two triangles highlighted here. We already know that OA is equal to OB. Also BF and AF are the same because F is a midpoint. And there's a third shared side OF. So again, these two triangles are congruent using the SSS rule. Since the triangles are congruent, it means that these two angles marked here are equal. And these angles sum up to 180 degrees, so each of these has to be a right angle. So we have proven that OF is perpendicular to AB, and so it's a perpendicular bisector. So this implies that all three perpendicular bisectors of the triangle have to intersect at the same point. Now since OA is equidistant from all three vertices, a circle can be drawn centered at O with radius OC, and this circle will pass through all three vertices. This is called the circumcircle. We can also reason that this circle will completely enclose the triangle. If we connect O to any other point on AC other than the two endpoints, the length of this segment shown in blue will be less than the length of OC, because if we consider this highlighted blue right angle triangle, its dimensions are smaller than the triangle OEC. So this means that the length OX is always less than OC, the radius of the circumcircle. This means that all points between A and C on the shorter arc of the circumcircle lie above the line AC, and a similar argument can be made for the other sides. So this proves that the circumcircle completely encloses the triangle. Next, we're going to derive the formula for the central angles for an acute triangle first. We already proved that O is equidistant from the three vertices. So this implies that triangle BOC is an isosceles triangle and these two angles have to be equal. I'm going to call both of them measure X. Similarly, triangle AOB, the same thing applies, it's an isosceles triangle. So these two angles marked here with double crescents are also equal. I'm going to call them Y. Now I'm going to extend line BO such that it intersects AC at point P. So let's see what the measure of angle AOC is. AOC is composed of two smaller angles, angle AOP and angle POC. Now let's look at what angle AOP is. So angle AOP is the external angle for triangle AOB. This means that angle AOP is the sum of two internal angles, both of measure Y, so its measure is 2 times Y. Similarly, POC is the external angle for triangle BOC, so its measure is X plus X or 2X. So the sum of these two is 2 times Y plus X, and Y plus X is the angle B. So we have proven that angle AOC is twice the measure of angle B when the angle B is acute. Next, let's look at an obtuse triangle. B is an obtuse angle. Let's find the measure of the central angle opposite B. Again, the circumcenter in this case lies outside the triangle. These three lengths highlighted in purple are the same. Triangle AOB is an isosceles triangle, so these two angles highlighted in light blue are equal. I'm going to call both these angles X. Similarly, triangle BOC is isosceles. The two angles highlighted in dark blue are also equal and I'm calling both of them Y. Now angle AOC is composed of two parts, again angle AOB and angle BOC. Now if we look at angle AOB in triangle AOB, its measure is 180 minus the other two angles, 180 minus 2x, and similarly the measure of angle BOC will be 180 minus 2 times y, 2 times 180 minus 2x minus 2y, or 2 times 180 minus x plus y. Now x plus y is angle B, so the formula for angle AOC opposite the obtuse angle B is 2 times 180 minus angle B. Next, let's also find the formula for angle BOC for this obtuse triangle case, where the circumcenter lies outside the triangle. If we extend these dotted lines as shown, angle BOC is the same as the measure of its opposite angle, and that angle can be expressed as the difference of these two highlighted angles, the angle shown in light blue and the angle shown in pink. The angle shown in light blue is an external angle for the triangle AOB, so it is the sum of the two internal angles, which is 2x, and we have to subtract from it the measure of angle shown in pink. This angle is the external angle of triangle ACO. I'm going to mark these two angles as z each. So BOC is 2 times x minus z. Now if you look at what x minus z is, it is the angle marked here, which is the angle A. So the measure of angle BOC is twice measure of angle A. So this is the same formula we obtained earlier for the acute triangle case. The last set of properties relate to the location of the circumcenter. For the right triangle, we will show that the circumcenter coincides with the midpoint of the hypotenuse. Consider this right triangle ABC. I'm going to draw the perpendicular bisector of BC. Let's say it intersects the opposite side at point X. If we consider triangle ABC and compare it to triangle XDC, they are both right angle triangles and they also share the angle C. This means that they are similar triangles. This means the ratio BC to DC will be the same as the ratio AC to XC, which implies that AC by XC is 2, or X is the midpoint of AC. So X is the midpoint of AC, and we know the perpendicular bisector of AC has to pass through X. So it means that the circumcenter O is the same as point X, because X is the point where both perpendicular bisectors intersect. Now let's look at the obtuse triangle case. I'm going to find the midpoint F of AB, and I'm going to draw a line starting at F, which is parallel to BC. Now by the same argument, the smaller triangle AFX is similar to triangle ABC. So again, X is the midpoint of AC. So the perpendicular bisector of AC has to pass through X. So next we'll prove that the circumcenter will lie above the line AC on the perpendicular bisector. In other words, in the direction of the arrow above the line AC. Next, I'm going to draw the perpendicular bisector of segment AB. So angle B is known to be obtuse, which means that the angle BFX will be acute as they both sum to 180. Also, the total angle here is 90 degrees, which means the angle OFX has to be a positive acute angle, 90 minus whatever is angle BFX. So this means that this perpendicular bisector rises above the line FX, and the two perpendicular bisectors will have to intersect outside the triangle. And finally, for acute triangles, a similar argument can be used to show that the perpendicular bisectors will converge towards the inside of the triangle. So the circumcenter for an acute triangle will lie inside the triangle.